Would you like to get the chance to win a ROS developer's shirt and practice some ROS along the way? Then stay with me. This video is for you. Hello ROS developers and welcome back to this ROS Mini Challenge video series. So after this small Christmas break, I hope you all have a great holidays, great time with your family, friends and loved ones. But now we are back here in order to solve these challenges, these ROS challenges, and being able to win an amazing ROS developers t-shirt like this one. So for those ones who are new and don't know what this is, so the ROS Mini Challenge basically is a challenge hosted by the construct where you are presented with a ROS-related problem that needs to be solved by you. And the fastest one to solve this challenge and share the ROSject with the solution with us will win the prize, will win this amazing ROS developers t-shirt. So yeah, let's start. Let's go straight to the point. So let's first of all get a copy of this challenge into our workspace, into ROS.ds. First thing we need to do, so here I have my copy of ROS Mini Challenge number 8, which is a beginner level one. I'm going to start open it so it starts loading. And meanwhile, I'm going to explain a couple of things. It will take, it's quick to load, so let's try to explain a couple of things. First of all, as you can see, this is a beginner level challenge. So basically there are 3 levels: beginner level, intermediate level, and advanced level. So this is the easiest one to solve. You will see that it's very easy to solve. With a little ROS knowledge, you are going to be able to solve it, this one. So, but yeah, we are going to explore it now when the project is loaded. And the other thing I want to talk about is about our academy, our Robotics Ignite Academy here, where we have all our online ROS courses, where we are going to be able to get all the ROS knowledge you need in order to solve these challenges and in order to work in any robotics project for companies, etc. Yeah, here I entered the path. But basically here you can see a list with all the courses we have: ROS Basics, Python and C++ versions, Python 3 and Linux, which are free, by the way. You can do this without paying anything. They are completely free and they are very interesting. So I really encourage you to try them. We have here a developing web interfaces for ROS, which is quite new. It's 1 month old, this course. It's super interesting. We have our brand new course, which is using NVIDIA Jetson Nano with ROS. Super interesting, amazing content. I really encourage you to try it. And this course has been published this week, I believe, so it's super new. And well, you have many other topics: deep learning with domain randomization, ROS2, fusing sensor data, unit testing, ROS navigation, perception, manipulation, etc. Many ROS courses, so have a look, and if you are interested in any of them, just go for it, because you are going to really learn doing these courses. So yeah, I really encourage you to try them. And okay, let's go back to our ROS.ds. Here we have already loaded our ROSject. Excellent. So let's make this notebook a little bit bigger so that we can read it better. There we go. So yeah, first thing we are going to do is to start following the instructions. The first thing is to launch the simulation, of course. So we are going to come here and select this ROSject of the week 8.launch. Here, choose launch file. And from the Turtlebot Gazebo package, we're going to select this launch file, the one indicated in the picture here. And this is going to start our simulation. And if everything goes fine, we are going to get a simulation like this one. So here we have a Turtlebot robot, as you can see, a Turtlebot 2 robot within a kind of room. Yeah, here covered by walls, by brick walls. So yeah, once our simulation is loaded, which is being loaded here, our gazebo simulation, the next thing we need to do is to start following the instructions here in the problem to solve. So here it is described. So it basically says, as you can see, this project contains one package inside the Catkin workspace, which is ROSject of the week 8_ package. So here we have our simulation loaded. Excellent. As you can see, it's here the Turtlebot within this small room. Excellent. And now here it's saying that we have a package in our CAD workspace. So let's open the IDE, which is going to allow us to visualize graphically all our workspaces and files. So there we go. Here we have the CAD workspace, and inside here we have a package which is called ROSject of the Week 8 package. Yeah. So here we have it. And this package contains a very simple Python script which contains a Python class named challenge. So let's come here and open this SRC folder, and here we have our Python script as the notebook says, and here we have our class named challenge. Okay, so good so far. So far so good. With some functions in it. Yeah, here we have the functions defined inside this class, and the main purpose, dismiss. The main purpose of this script is to get the highest value from all the laser readings and also the position in the array of this particular reading. Okay, so yeah, basically here we have our touchable robot which has a laser mounted on it. You can see it right here, a Hokuyo laser in fact, and this laser is providing readings from the environment. So basically this Hokuyo laser has a range and a scope, let's say, of 180 degrees. So more or less it will cover all this area, 180 degrees here in front of the Turtlebot robot. And this is full of readings. So as you know, this laser is sending beams which give information to the robot about the environment. And basically we need to so the purpose of this script is to get the highest value from all the laser readings and also the position in the array of this particular reading. So all these readings, which if I'm not wrong are 720 readings, different readings, that will cover this scope here, 180 degrees, contain values, yes? So for instance, the ones that are here will have low values, because they are detecting this wall here close to a robot at 1 meter more or less, I would say. So well, let's continue, and now I'm going to explain a little bit more. So in order to reproduce this, let's execute this command. So first of all, we are going to source our workspace. We will need a shell here to open a new web shell. There we go. So let's source our workspace, and now we are going to run our Python script, the one we have here. So let's run it and let's see what we get here. And here basically it says if everything is correct, you will get a message like this in the shell. So the message we should get is highest value is 7.2 more or less, and it is in the position 202 of the array, 202 out of 720. Remember this? And here it says, note, the numbers in the value of the maxim and the maxim and the position in the array may vary a little bit from the ones in the image below, but not much in the image above. But not much. So there's a small error that can vary this value and this one as well, but they should be very similar to these ones. And we are getting, first of all, an error, but let's run the code now. Okay, so here we can see that the highest value is 4.49, so 4.5 more or less, and it is in the position 0 of the array. Okay, so this is very different from these ones. It's almost 2 meters difference, which is a lot, and the position as well, it's 200 positions. So for sure this is not correct. This is wrong. In fact, if we analyze this data, this is saying that the highest value is 7.2 and it's in the position 202 of the array. So if we come here and we look here what the front of the robot is seeing, which is this, remember that this laser is covering 180 degrees, and I can tell you that the position 0 of the array is here. And the position 719 is around here. So here in the middle we will have the position 360 more or less. So the position 202 would be here between the 360 and the 0 position. So more or less it will be somewhere around here, which makes totally sense, because if you analyze the environment, the largest distance between the robot and the wall is here. So this is the largest distance. Not here, not here, not here, not here, not here even, but here. Yeah, this is the largest distance, and it makes sense. It's the position 202 of the array, because it's between the position 0 here and the position 360 here, and it also makes sense that it's 7 meters more or less. Yeah, here with an eye calculation, it makes sense that this is 7 meters and that this reading is in the position 202 of the array. Yeah, so for sure it's not the position 0, because the position 0 is this one. And for instance, just this position here in front, it's higher than this one. Yeah, here with an eye calculation, you can see here 1, 2, 3, 4.5 square meters, and in front we have 1, 2, 3, 4, 5.5. So just the position 360 will be higher than the 0 position, which is around here. Yeah, so for sure this is wrong. Then what's going on here? So now what we should do is to analyze the code, as it's said here, to have a look at the Python script inside the package. So we should have a look here at our Python script, what's going on here. So as you can see here, we have the challenge class, and in the constructor, we are basically defining here the laser message, which we are importing here, and we are creating a subscriber to the Kabuki laser scan topic. So first thing we should do is to verify that this topic exists. So ROS topic list, and we should have here a topic which is named Kabuki laser scan. Okay, so the topic exists at least. And now, is something being published into this topic? This is the next thing we need to ask ourselves. ROS topic echo Kabuki laser scan. Let's see if, okay, yeah, so we are having data published here. So apparently this is the correct topic. So no error here. So let's continue analyzing. So here we have the laser callback, where we are basically getting the messages published into this topic, and we are storing them into this laser message variable constantly. Yes. So this laser message variable will contain all the updated laser data which is being published into this topic. Yeah. Okay. So far so good. This is also correct. And here we have a function which says get laser full. So this function, let's check here the get highest lowest value, because this will help us understand the word process. So basically here we are calling a function which is to get laser full. So basically this function, what it's supposed to do is to get all the readings, yeah? Because we need to get all the laser readings, all the full array with all the 720 different readings, and between all of them, check for the highest one. Yes? If we don't have all the readings, we cannot check for the highest one, because we are not sure that we will have the highest one. Yeah? So we need all the readings. Then when we have all the readings, we are going to check here for the highest one, here in this for loop. So basically we define an e variable, which is initialized to 0, and a maxim variable, which is initialized to -1. Then here we create a loop that from all the values in the array L, which are here in the array L, we are going to check value for value. Yeah, so we are going to access each value in this L array, and then for each value we are going to check that is higher than the maxim, which is -1, and that the value is not infinite. Yes, because it is possible that we are going to get some infinite values from readings around here. Yes, because they will not collide with any wall. They are going to go outside the room, and they will reach the maximum value possible, which is 30 meters, and then they will receive an infinite value. So we don't want to consider these ones, we just want to consider the ones that currently are returning a value. So this is why we are adding here this check. Then if the value is higher than the maxim, we are going to assign this value to be the new maxim, yeah, for future comparisons here. And then we are going to store the position here in the max pose variable. We are going to store the e position. Yes, which will be the position in the array. Yes? Why? Because this E value, we are going to be increasing it in 1 for each iteration. Yes? So, after the first iteration, we will have here the E to 1, and the maximum, it will be the new maximum value. Yes? So this is a quite simple logic. So basically we are going to constantly be comparing the new value from the array with the current maxim. If it is higher, we are going to update the maxim value, and we are going to store the position in the array, which is represented by this E, into the max pos variable. Yes? And then we are going to just, at the end, when this for loop finishes, we are going to print here the highest value, which will be the maxim, will be stored here in the maxim, and we are going to print as well the position in the array, which it will be stored here in this max pos variable. Yes? So this logic also is correct. Yeah? You could use another logic, okay, but this logic should work. So what this is telling me is that probably the error is here. And yes, it's pretty easy to detect here the error. So here we should be getting all the laser readings, but instead we are just returning the position 0 and the position 719. Yes? So we are not getting the full array. Yes? We are just getting, as you can see here, the position 719 and the position 0. So only 2 readings. Yes? That is why here we are getting the position. So let me run it again. That's why here we are getting the position 0 and this 4.5 value, yes, because it's comparing it with the 719 position in the array. So basically, the current code, what it's doing is to get the position, the reading here, which is 0, and the reading here, which is the 719. And of course, the 0 position, the 0 reading is higher than this one, yes, because there's more distance to the wall. So that's why we are getting this message here, yeah? So basically what we have to do here is to get all the reading from the array, yes, the full array. And how can we do this? Well, we just get the wall ranges array without, basically without this specific position that is defined here, yes? And we then can remove as well this. So this way we are going to get the full array with all the readings, yeah? Alright, so let me save this new code and let me execute it again and see what happens now. So let's execute this modified code here, and in fact now we are getting highest value is 7.2, which as you can see it's very similar to this one, and the position in the array is 203, which is also super similar to this one. So here we have a small error, which is already noticed here in this node here. You can see that this can happen, a small error, but we can see now that this is correct. So the program now is working properly. Yeah? So we have basically solved this challenge. Yeah, so as you can see, it's been pretty easy. So you just have to have a little knowledge about how laser scan messages work, and yeah, know a little bit how a class works as well. Some basic concepts about ROS, but it's very easy to detect the error and to solve it. So I hope many of you have achieved it, have solved this mini challenge. And yeah, that's all for the video of today. So I hope you've enjoyed it, you've learned something new, and I will see you next week in ROS Mini Challenge number 9. So goodbye and keep pushing your ROS learning. Bye bye.